Alright, let's take a look at this problem. Summation n equals 7 to 200 of 3n plus 1. And I'll actually give two different ways of doing this that both work. First things first, let's just plug in. If I plug in 7, I get 22. If I were to plug in 8, I get 24 plus 1 is 25. If I were to plug in 9, I'd get 27 plus 1 is 28. And at the very end, if I were to plug in 200, I get 600 plus 1 makes 601. And I recognize that this is an arithmetic series. And my formula for an arithmetic series is going to be n over 2 times the first term plus the last term. In my case, I have 194 terms. 200 minus 7 plus 1. Another way of looking at it, I have 200 terms, but I take off the first 6 from 1 to 6 because I'm starting on 7. So 200 minus 6 makes 194 terms. So 194 terms. The first term, the n equals 7 term, is 22. The next term is, the last term is 601. And so just simply doing the arithmetic, we get 60,431, and that is the sum of this of these terms. So that's one way to do it, and there's absolutely nothing wrong with that technique. I want to show a second way of doing it that's not necessarily superior, but it's something that you ought to be familiar with when doing a problem like this. And the way that we'll do this is as follows. Summation n equals 7 to 200 of 3n plus 1. That's equal to, well, let's write it as the sum from 1 to 200 of 3n plus 1 minus the sum n equals 1 to 6 of 3n plus 1, where I am explicitly subtracting off the first 6 terms. So from 1 to 200, but I'm going to take away from 1 to 6, and that would give me from 7 to 200. Okay, so this is equal to summation n equals 1 to 200 of 3n. Then summation n equals 1 to 200 of just 1. And then these parts here would be summation n equals 1 to 6 of 3 times n. And then summation n equals 1 to 6 of 1 all by itself. Then for all of these, I can apply the formulas. The formula for this, summation n equals 1 to 200 of n, is going to be n, this number of terms, times number of terms plus 1 divided by 2. If I add 1 to itself 200 times, that's 200 times 1. Over here, this sum is going to be 6 times 7 over 2 using the formula. And then this last one, I have 1 added to itself 6 times, so 6 times 1. And then once again, this is equal to 60,431. Now, the advantage of this technique is that this works even if I have an n squared or an n cubed that would allow me to evaluate something like this. For this particular example, that was not entirely required because starting on 7, the series would still be arithmetic. So because this happened to be an arithmetic sequence or an arithmetic series, it was not necessary to break it up from 1 to 200 and subtract off 1 to 6. I could get at it directly using the formula for an arithmetic sequence. But it was certainly possible to do it this way, and this second technique would work even if the series was not arithmetic.